Hi, my name is David Clark, and for my science experiment, I did wind speed by distance. There we go. So my question was, what is the effective distance from a source of wind on wind speed? And my prediction was that the closer it was to a source, the higher the wind speed will be. Now, I did this because this aligns with the fifth grade science standard about how temperature, pressure, humidity, wind direction, and wind speed are all used to determine the climate in a particular place and time for the area. And actually, as part of that standard, they want students to be able to explore one of these devices or one of these tools in order to actually interact with it. So I built a device called an anemometer, which is actually in my vocab word. And the whole idea is that it's kind of falling apart. But these different cups would catch the wind. I'm not sure if it will work. I'll try to show it off a little bit. But it would catch the wind from a fan like this and spin. But as I've said, this version of it is falling apart. So it doesn't spin all that well. But what scientists would do, actually, I still need this again, that they would mark one of these little cups, right? And for every rotation that it completed, that'd be known as one. So that is what I actually recorded here with my variables and all the materials that I had used in order to make it, including straws, the cups, as you saw, a little needle holding together, a pencil, and my little electric fan. And that's how you put it together. The whole point is that you use these in order to see so I could collect the data, see how many spins it did. Because for my experiment, I did a minute for each thing, from each of the distances. And for my control, I had put it outside, as you saw in that photo back here, right? Just out on the ground, high enough. This is actually kind of a bad photo because it wasn't touching the ground, but I did have the pencil actually jabbed into it about that far. And normally these would be horizontal instead of being vertical like that. But with the wind gusts, because that meant the reason why I use that for my control is because I can't control where the wind comes from or how often the wind comes. As you can see on the different days that I'd done it, there was not much wind. I got a couple of strong gusts during my fourth trial, but there really wasn't many. And then as I looked at my different distances, you can see 2 feet, which I had measured out. It got a couple, really, it was kind of struggling in order to super catch it all that well. But the 1 foot, I got a lot stronger of a result. And part of that was because of the strength of my fan, I know is part of my result, and also the strength of the anemometer. Clearly, this is one made out of paper, a pencil, a couple of straws, and some tape in order to hold it together, rather than actually being a metallic rod and cup system. So from that, I was able to find out these different little statistics and actually graph it over which one. And it ended up being what I thought was that the closer the distance, the more rotations I was going to see. And those rotations per minute actually shows me the speed at which the wind is traveling. So what I would do is I would take, say, if I had 5 rotations per minute, because I hadn't explained that part yet, 5 rotations per minute, I would then divide that by 60 seconds, or using my 60 seconds, I could figure out what the wind speed is because I have my number of rotations. That would be my D over R equals D over T. So yeah, 5 divided by 60 or to figure out what my wind speed was. The experiment. So like I said, here are the results, with average rotations being at a 6.1 per minute, 1.7, and my control group having the absolute lowest were the major results of my experiment. I was going through things. And before I get to my conclusion, I just want to go through my diary. So I had done this over the course of 9 separate days. And after gathering my materials, that was really the easiest. This was actually super fun because I built one to bring into the class. Like I built an anemometer. This is not the one I brought into the class during the day when I taught my lesson plan on weather instruments. That's what I taught them about. So I already knew how to make one. So it made doing this science experiment really applicable, both to me, because I had already taught the material behind it, and also easy to do because I knew what I had to do. So I was able to build it just within a day. And then I wrote out the steps the next day and began running all of my trials and calculating all of the information that I needed. Now, for a real world application, this is exactly what a meteorologist would be doing, not with these, but with these really nice high-tech versions of it, where they even have other weather tools combined with them, such as probably barometric pressures or thermometers could be combined with that, hygrometers in order to measure the humidity. But mainly you see a lot of anemometers and wind vanes. One actual great way to connect this to the students, and one thing that I did use during my lesson, was if they had ever seen the movie Twister. It is a classic film and a very popular one. And if you know, outside of the mother's house, there's all those metal sheets that she had, right? That just kept spinning when the wind picked up. Those are all technically anemometers. The only thing that they're missing is the fact that no one's measuring the number of rotations. But that's why she has them, in order to sort of alert her when the wind kicks up or to measure wind speed. So during this, I learned a couple of things. And one of the major things that I had noticed, and one of the major problems I had when running this experiment, is that while I liked my control, the wind gusts super close to the ground, I think both the grass and there was actually a nearby tree that just happened to be in the way from where the wind was blowing on that particular, like on the days when I was collecting that stuff. I think that that got in the way and really hurt my control group. But and also it being so low to the ground, like I wish I'd had a way to mount it higher up, because normally these aren't mounted on the ground. Like when you look at a real anemometer, they are mounted, like if this was like, sorry, if this was the top of a building, right? Normally they'd be mounted either here on the ground or up here, like on the top of like a giant flagpole, because they need to measure that high up, and they do it a lot above buildings, or they do it in open field. That exact reason of there's not as many things that could be getting in the way and blocking the wind path. So that way they could actually keep measuring. Another discovery that I made was obviously being close to the source increased the wind speed. And I think I had the issue because it ran better when I was running this experiment than when I'd shown it off to the class. And I believe part of that is because of the fan that I was using. It blows wind over the whole thing, which I know that this video won't be able to show it. But what I was able to discover is my thing spun faster when I had it set up to spin counterclockwise, to spin clockwise. Because the first time I had done this, when I did it with the kids, I centered the anemometer here in front of the fan. What I found out is I was getting better results when I offset the anemometer, like putting it over here. And the reason for that is because the wind was catching in my cups and causing it to spin. But when I set it in the center, it was blowing both sides. So it kept trying to balance out and was actually stopping the device from working. So this method ended up being a lot more effective when I changed that. And I really would not have caught that had I not brought this into the classroom. It was really fun in order to learn. And I did actually show this experiment to my students later, or to be like, hey guys, like, look at this, because it was super fun. And they really enjoyed it and enjoyed getting hands-on with all the different weather tools. Well, with this weather tool, I really wish I could have given them an in-depth experience with the others, but there's just was not any time, sadly. But that is my experiment on wind speed by distance. Thank you so much and have a good day.